Hi, in this video I'm going to talk about equivalent fractions. That means a variety of different fractions which are equal to each other. Equivalent means equal. I'm not writing their numerators and denominators yet, but I'm going to show that all these different fractions here are really the same way of writing the same thing. It just looks a little different. So first I'm going to start with a whole circle, and I'm going to break it into two pieces. And I'm going to shade with a permanent color here that I cannot erase any of, this much of the circle. So the part that I have of the circle, my yellow part, is not going to change this whole time. Right now I have one part out of two equal parts total. So I've colored in, I have this half of my circle. But what we can do is say, hey, let's actually break each of these pieces up a little bit. I'm going to cut this piece into two, and I'm also going to make this one piece into two. So now we can see that I have four pieces all together. And how many of those four have I colored? Well, two of them. So I've just shown here that 1/2 is really the same as 2/4. So the 2 has doubled to 4 because I drew in these extra lines. But now instead of only having 1 like before, the 1 is also doubled to 2. I have 2 pieces. Let's do another one. Let me now split each of these pieces into 3. So my 4 is actually going to triple to 12. So I'm going to take this piece and split it into 3. I'm going to take this piece and split it into 1, 2, and then here's the third. It's already written there. And then I'm going to split this piece into 1, 2, and the third line was already drawn in, and then 1, 2, and the third line was already there. So now we can count. I have 3, 4, 5, 6, 7, 8, 9, 10, 12 pieces all together. And how many of those pieces are shaded in? We can see there's just 6. So the 4 tripled to 12, but then the 2 also tripled to 6. So these fractions are all equivalent. Lastly, I'm going to do something funky here, and I am going to make a fraction of 6. So I have 12 pieces here, but I'm actually going to break them into 6. So I don't know how it's going to work here actually, but I'm going to cut this off. So I'm going to have one piece here. I'm going to cut these two pieces and put them together into one. That's a second piece. This is a third piece. 4, 5, 6 pieces. So now my pie has 6 pieces all together, and I took each of the 2 pieces and combined them into 1. So effectively I kind of divided this by 2. And what happens then is I also need to divide my numerator 6 by 2 as well to get 3. And in fact, it is true, out of these 6 blue pieces that I have here in the pie altogether, the number that I have shaded is 3. So all of these fractions are equivalent. They're all equal to each other. They're all the same way of saying the same thing here, of the same picture with this yellow part shaded. Now, when we go to adding and subtracting fractions, understanding this is very crucial. So sometimes when we go to add or subtract fractions, we'll have it in a form where the numerator and the denominator are pretty small numbers, just little 1 and 2. But in order to get a common denominator, we might want a denominator to be bigger. So we might need to multiply it by something to get it in this bigger form. So here we might multiply the 2 by 6 to get 12 and the 1 by 6 to get 6. We might want to use this one more than this one. Or if we end up getting something like this as our final answer, we might need to reduce it back to this original form. But whether we go from this to this, or this to this, or this to this, whatever we do, these really are all the same thing. They're all this yellow part right here. So we're allowed to go back and forth between the two if it will help us. So here's an example of where that might help us. I'm going to do a problem that is 3/4, and I want to, let's see what I want to do. I want to add 1/12. So for this problem, first we're always going to draw a picture. I'm going to take a whole thing, I'm going to split it into 4 pieces, and I'm going to shade 3 of them. So I have 3 out of 4 pieces here. And I want to add even more onto this. I want to add a 12th onto this. So I can draw this picture separately, but I'm actually going to draw it on top of this. So I'm going to draw a 12th. Well, the problem is this is only divided into 4 pieces right now. So I need it to be into 12 pieces. So I'm going to need to split each one of these pieces into something. Let me see how to say this. So I cannot add 1/12 now because I have 3 pieces, but these are 3 big pieces. And a 12th is actually a very small sliver. So what I'm going to do is I'm going to change 3/4. I'm going to make it into something with 12ths so that when I go ahead and add my 1/12, I can do that. So in order for the 4ths to become 12ths, 4 times 3 is 12. I'm going to need to divide each one of these pieces into 3. And this one into 3, this one into 3, and this one into 3. So I'm just making an equivalent fraction here. 3/4 is the same as how many 12ths? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. That's just the same as 9/12. Cool. So I already have 9/12. I've switched to a different equivalent fraction that's going to be more helpful in this situation. And I want to add one more 12th. I'm going to do that with a different color in here. Here's one more 12th I'm adding in. Yay! All right. So how many 12ths do I have altogether now? I have these 9 plus 1 more, so I have 10 of those 12ths altogether. We can see that in the picture. Now the last step here is that in math, if we have a fraction with bigger numbers and we can reduce it to a fraction with smaller numbers that's still the same thing, then we like to do that. We like to reduce. So I'm looking at 10 and 12, and I'm seeing they're both even numbers. I'm realizing that in this picture here, I can divide it by 2. I can make it so we have half as many pieces. Half of 12 is 6. But then that means I'm going to have half as many colored in. Half of 10 is 5. So let me see. I think my final answer is going to be 5, 6, but let's prove it in our picture. How will I do this with my pens? So I am going to take these 2 pieces that I don't have and kind of erase this. So now this is really just one big piece. How can I do that? It gets a little tricky here. Okay. So I've got one piece there, and then I'm going to cut these. Instead of 2 pieces, I'm going to count these as 1, and I'm going to erase this, and I count these 2 pieces together as 1, and I'll erase this, I'll erase this, and I'll erase this. Now I can see that it really is true. I had these yellow ones before, and then I added this blue one in here. So now I really do have 1, 2, 3, 4, 5 full pieces out of a pie that has 6 pieces altogether. So 5, 6 is my final answer. Let's do one more where we have to get common denominators. So in this problem here, I'm going to look at, let's do our colors. Life is more fun in color, right? We're going to do 1/3, and we're going to add 2/5 to it. So I'm going to draw a picture of 1/3. So I'm going to cut my pie in 3 pieces, and I'm just going to shade one of those pieces. I'm going to shade 1 out of the 3. And now for this one, when adding the 2/5, I'm just going to do my own separate circle for now. I'm going to cut this in 5, which is always a little tricky too, but okay. There, and then here. So we're just going to pretend that all 5 of these are the same size because they really do need to be for math. I'm not the best artist, but that's all right. So I'm going to shade in 2 out of these 5 pieces. So for addition, I want to smush these together. Maybe I could kind of pretend I'm picking up these 2 and putting it in the same pie over here. But the problem is I'd have one big piece of pie and two smaller pieces of pie. We really need the pie slices to be the same size if we're going to combine them. So that means we need the denominators to be the same because the denominators talk about size. I'm going to go ahead and kind of keep everything in line here. So this is 1/3, but I'm actually going to rewrite 1/3. I want to get this so that it has a certain denominator down here. And whatever denominator I have down here, whatever the size of these pieces, needs to be the same as the denominator over here. I want to get common denominators so that I can then add these two fractions together here. So I think, well, if I cut each of these pieces in half, I could get this denominator to be 6. That's a possibility. Or if I cut each of these pieces in 3, I could get this denominator to be 9. Or if I cut each piece in 4, I could get the denominator to be 12. I could end up getting 15 pieces if I cut each of these in 5. 3 times 5 is 15. If I cut each of these in 6, I could get 18. There's a lot of things I could get for the denominator depending on how I want to cut up this pie. But in order to make a decision, let me look at this pie here. This pie is in fifths. And 5 could be multiplied. I could leave it as it is as fifths, or I could cut each in half to get tenths, or I could cut each into 3 pieces. 5 times 3 is 15, or each into 4 pieces. 5 times 4 would be 20. Oops. I could do any of those choices. Which decision should I make? Well, I'm looking at these common multiples. These are the multiples of 3 and the multiples of 5, and I'm looking and seeing that 15 is a common multiple of both of them. So I'm going to go ahead and get both of these denominators to 15 then. I'm going to cut up both of these pies so that they both have 15 slices total. So in order to do that here, I already have 3 pieces. The way I get 3 to 15 is I multiply it by 5. Let me do a different color. Maybe for colors. I'm going to multiply 3 by 5. So in other words, I'm going to take each of these 3 pieces and split up into 5. I'm going to cut 1, 2, 3, 4, and the 5th cut is already there, so I can just do it on top. 1, 2, 3, 4, and the 5th is already there. 1, 2, 3, 4, and the 5th cut is already there. So now I've cut this pie into 15 pieces. Excellent. And I can see that I've already shaded in 1, 2, 3, 5 of them. So 1/3 is really equivalent to 5/15. And I'm going to use 5/15 now so that they can be the same denominator. And in fact, that makes sense. 3 times 5 is 15. And then 1 times 5, we want to multiply the numerator and denominator by the same thing as 5. Because I have 5 shaded pieces out of the 15. So over here, I want to break this pie into 15 pieces as well. It's already in 5 pieces. 5 times 3 is 15. So let's break each one of these 5 into 3. 1, 2, 3. 2 lines to make 3 pieces. 2 lines to make 3. 2 lines to make 3. Again, I'm not a perfect artist, but we're going to pretend that all these pieces are the same size, because they really should be if I was perfect there. And now I have 15 pieces, but I don't still just only have 2 of the 15 pieces. Now I have more than 2 of the 15 pieces. Let's multiply this by 3 as well. And 2 times 3 is 6. Do I have 6 of the 15? Let me see. 1, 2, 3, 4, 5, 6. I do. Out of 7, 8, 9, 10, 11, 12, 13, 14, 15. So I do have 6 out of 15 pieces. So now I'm ready to add them together. I can take these 6 pieces, and they're the same size as these pieces, so now I can shade in. Let me get a lighter color here. So I'm going to move these 6 over to here. There's 1, 2, 3, 4, 5, 6. So indeed, I've added them together. These guys I've put over here. So now the question is, how much do I have all together? Well, my slices are in 15ths, and I can see that I had 5 before, and now I have 6 more, so I have 11 of these 15ths all together. This is my final answer. I can't reduce that anymore. So 1/3 plus 2/5 is equal to 11/15.